Next we are discussing if function y equal to fx is symmetric about x equal to 0. So instead of what we are writing x equal to 0, then that function is called even function. And what is the condition will come? F of a minus r should be equal to f of a plus r for all r belongs to capital R. So this one what we can write, a value is 0, so what will come here, f of minus r should be equal to f of r for all r belongs to capital R. So instead of r we can write x also, so we can say that f of minus x equal to f of x for all x belongs to r. Then we can say function is even function. So function is even function if x equal to 0. Okay, with respect to x equal to 0, left side and right side both graphs should be what, mirror image of each other. That means x equal to 0 is nothing but y axis. So if function should be symmetric about y axis, then that function we can say even function. And condition is what, f of minus x equal to f of x. Okay, so this is the condition for even function. We have discussed condition for even functions. If a function is called even function, then first thing what we have to check, domain should be symmetric. If domain is symmetric, then second thing what you have to check, f of minus x should be equal to fx. If f of minus x equal to f of x, then we can say function is even function. For example, y equal to fx equal to cos x is given. Okay, so cos x domain if you check, it will come minus infinite to infinite. So we can say domain is symmetric about origin. Correct? From origin, left hand side is what, 0 to infinite, and right hand side is what, minus infinite to 0. So domain is symmetric. So first thing is what, domain is symmetric. Next thing what you have to check, instead of x replace with minus x. So what will come, f of minus x. So here what will come, cos of minus x. We know cos of minus x is what, cos x. So this one we can write cos x. And cos x is nothing but fx. So this is not fx. So here what we can say, f of minus x equal to f of x. Then we can say that y equal to fx is even function. So this is even function. And if you check graph also, so graph will be symmetric about y axis will come. This is y axis, this is x axis. So this type of graph will come. It will be continued like that. So this is what, symmetric about y axis. Okay, next we are discussing even extension. So what is even extension? This I am discussing by example. So example is, we know y equal to fx is even function. This is given, even function, such that fx equal to e power x for x greater than equal to 0. Okay, x greater than equal to 0. Then find the function for x less than 0. Okay, so fx is even function, that means what, it is symmetric about y axis. Okay, so we can take, this is x axis, this is y axis. So graph should be symmetric about y axis. Okay, this is origin. Given is what, fx equal to e power x for all x greater than equal to 0. So x greater than equal to 0 is what, this side. Okay, right hand side of y axis. So x is greater than equal to 0 here, this portion. Okay, in this portion what is the function, e power x. So that means e power x graph if I draw, so this is what, 0, 1. So look at this graph. So this is what, fx equal to what, e power x. Okay, but given is what, fx is even function. Okay, so even function is what, symmetric about y axis. So this side graph we know, so we can find out this side graph because fx is what, even function, that means graph is symmetric. So graph will come this side also. So what will come? This side graph will come. But we want, what is this function? What is this function? So to understand this one, we are doing separate graph. Okay. So this is origin, this is x-axis, this is y-axis. So this is what 0, 1, 0, 1. This is what fx equal to what? E power x. Okay. And this side graph is what? This one. So here, this is x-axis, this is y-axis, this is origin, and this is what? 0, 1, and this one is there. Okay. So this function we know, we have to find out this function, and graph we know. So you can see here, this is y-axis. So first thing is what? Analyze that from this graph to this graph, how to get. From this graph to this graph, how to get. So you can see here, this graph is this side. So if I rotate this graph with respect to y-axis 180 degree, okay, if I rotate this graph with respect to y-axis 180 degree, then this graph automatically will come this side. So we'll get this graph. So you are rotating with respect to y-axis. So for finding this graph, we are rotating this graph with respect to y-axis 180 degree. Then in function, what we have to do? So in transformation of graph, we have discussed, if I replace x with minus x, then we have to rotate the graph 180 degree with respect to y-axis. So only what we have to do here, instead of x, what we have to put? Minus x. So instead of x, what we have to put? Minus x. So what will come here? Fx equal to what will come? E power minus x. E power minus x. So okay, so here also if you put minus x, okay, and f of minus x is what? Fx, because fx is even function. F of minus x is what? Fx, because fx is even function. So here what is coming? Fx equal to what? E power minus x for all x less than 0. X less than 0. So we got left hand side, what should be the function? E power minus x. Okay, so what is the answer? E power minus x. Fx equal to e power minus x for x less than 0. Then we can say function is even function. So what we are doing, simple thing is that, see, from fx is even function such that x greater than or equal to 0, we have given function e power x. Then we want other side graph we want. So what you do, instead of x, we have to replace minus x. For example, fx is even function in such a way that gx RHS side. Then what should be the graph? LHS side. What is the function in LHS side? So what you will do here, instead of x, what you will put? Minus x. So what will become? G of minus x. Very simple is it. Next example is y equal to fx is even function such that fx equal to gx for all x belongs to -3 to -1 close interval. Then define the function. So here given is what? Fx is even function. So we have to define the function. Okay, graph is given. Okay, fx equal to gx is given. So this is what? -3 to -1. And given is what? Fx is even function. So if fx is even function, that means domain should be symmetric. Okay, if fx is even function, then domain should be symmetric. So what is the meaning of symmetric? You can see left hand side, what is the domain? -3 to -1. Okay, then right hand side also domain should be what? Symmetric. So where, okay, this is what? -3 to -1. So symmetrically what will come? See, -3 to -1. So we have to take symmetrically with respect to origin. So what point will come? 1 to 3. 1 to 3 will come. Okay, so this is y-axis, this is x-axis. So 1, 2 and 3. Okay, so here domain should be what? 1 to 3 should come. Okay, so what is the domain? Full domain will be what? -3 to -1 and 1 to 3. Because for even function, if you are getting graph between -3 to -1, then we should get graph between 1 to 3 also, and graph should be symmetric about y-axis. So here, how to take symmetric graph? So -2 to -1 we are getting this graph. So 1 to 2 we got this graph. Okay, and 2 to 3 we should get this graph. 2 to 3, we should get this graph. So this graph we should get. Okay, now we have to find out function also. Okay, what is this function? So you can see from this graph to this graph how to get. So if I rotate this graph with respect to y-axis 180 degree, then we will get this graph. Okay, so for finding this graph, what we will do? In function, we have to replace x with minus x. So in function, x we have to replace with minus x. Okay, so here function is what? G of x. So this function should be what? Fx equal to what? G of minus x. So how to define fx? Fx, it is given gx for x belongs to minus 3 to minus 1. Okay, then in this side 1 to 3, for x belongs to 1 to 3, fx must be g of minus x.